the next example goes. Example 2, saying evaluate log root 5 into 125 root 5. So the question goes, evaluate log 125 root 5 base root 5. Now you can see that the applicability here is going to be somehow challenging, but it's not challenging. You can see that they have just evaluated. When they say evaluate, they want you to come to the minimum point of it. So how do we handle such kind of a number in that manner? So we are going to start by saying let log of 125 root 5 base root 5 equals x. Then we apply our rule of the index. What is it going to be? It's going to be root 5 power x equals 125 root 5. From the other index, what we said, from the other rule which we have been having bind there. Then we said again from the rules of indices, these are rational indices. When it is a square root, it is like power a half. And even 125, we can break it on the factor tree, we break them. So we can start by breaking. We said root 5 is the same as 5 to power half. What about 125? Let me try to break. By 5, I get 25. By 5, I get 5. By 5, you get 1. So 125 alone is the same as 5 to power 3. So where you see 125, I'm going to put 5 power 3. Where you say square root, I'm just going to put 5 power a half. What comes here? This is 5 power half outside x equals, where there is 125, put 5 power 3 times this is 5 to power a half. So what we're going to do, we apply our rules of indices. This becomes 5 power x out of 2 equals, this is 5 power, we are adding. When I'm multiplying numbers of the same base, we add. So we're going to have 3 plus a half. What is the LCM? Is 2. 2 divided by 1, you get a 2. 2 times this, you get a 6 plus. 2 divided by 2, you get 1. Times that 1. So it becomes 7 out of 2. So where we see 3 times, when I use the point, it's like a times, again that. So this is the same as 5 power 7 out of 2. We also apply our idea of the rules of indices. Since the bases are the same, since the bases are the same, we equate the powers. We equate their powers. We're equating the powers of the left hand side together with those ones in the right hand side. So what is going to happen? 5 goes, we remain with x out of 2. X out of 2 equals 7 out of 2. This is 7 out of 2. Mathematically, the numerators are the same. They can use a cross, so you can cross multiply. So this and this one can die, can disappear, or cross multiply. Let's cross multiply. This is 2x equals this times this, you get 14 divided by 2. So x alone is 7. So x is 7. We say therefore log of 125 root of 5 base root 125, we are coming out with a 7. You have already tried to evaluate this one. That's how we're going to be doing more and more of the numbers. So let's proceed to the next example. 2. Example 2. Example 2 goes, given that log of x base 3 equals p and log of x base 15 and log of x base 15 equals r. Show that log of 3 base 5 equals r out of p minus r. That's the question which is on table, which we need now to look at. They have given us log of x base 3 equals p and log of x base 15 equals r. Show that this equals that. So what I'm going to do with this, we are going to apply the use of the indices. So from 1, we have said log of x base 3 equals p. This is the same as x equals 3 power p. I say this is the first equation. I also come to the next one. Log of x base 15 equals r. We still apply the index laws. This is x equals 15 power r. This is the second. What are you seeing between equation 1 and equation 2? All of them are related with x. You can say equating 1 with 2. Because this is x, this is x. We're going to equate equation 1 with equation 2. So what are we having? We are having 3 power p equals 15 power r. Check in the question. What are we having? We're having a log to base what? 5. That means you're going to take log to base 5 on both sides. So taking log to base 5 on both sides. So can we take those bases? So we're going to say log 3 power p base 5 equals log 15 power r base 5. So what we're going to do, when the power is up, it is brought in this side. What are we having? We have p log of 3 base 5 equals r log of 15 base 5. Again, from the factor formula, from the factors, 15 is related to 5. We can even break it. If we can break 15, so we can go p log of 3 base 5 equals r log, when we see 15, I will say 3 times 5 to base 5. Again, we apply the rules of logarithm. When we are multiplying numbers of the same base, addition arises. So this becomes p log of 3 base 5 equals r log 3 base 5. We are multiplying, we add plus log of 5 to base 5. So what we're going to do, then we are free to push in and we open up that bracket. So this becomes p log of 3 base 5 equals r log of 3 base 5 plus, we said log of a number related to a base is the same as 1. So r times 1, we just get r. Then you can see log of 3 base 5, log of 3 base 5, they are related. We collect like terms. So this becomes p log of 3 base 5 minus log minus r log of 3 base 5 equals r. So what is common here is log of 3 to base 5. So what am I remaining with? I'm remaining with p minus r log 3 base 5 equals r. So can we make log of 3 base 5 as in question? Log 3 base 5 is the same as r out of p minus r as required. So with solving, there is no need of you to do the gambling stuff. You need to follow the right procedures, following the rules of logarithm. Then you will come out with a clear stuff which they have already asked you on that. So that's what you can do as far as the applicability is concerned of sewing. You are going to do more